Hall Scott built engines powerful enough to drag 40-ton tanks through mud and help power landing craft headed for enemy beaches. For decades, they were unstoppable. Then, a quiet German invention called diesel showed up, and within 20 years, this American titan was dead. Hall Scott did not rise in the age of diesel. It rose in an older world, when big gasoline engines still made sense anywhere brute force mattered more than efficiency. The company started in Berkeley in the early 1900s, with Elbert Hall and Bert Scott building rail cars and power plants at a time when America was still figuring out what the internal combustion engine could become. They were not industrial giants. They were a small engine builder trying to prove that reliability could matter as much as raw power. That reputation started taking shape in aviation. In the 1910s, Hall Scott moved into aircraft engines, a field where failure was not just expensive, it could be fatal. Their early water-cooled engines helped give the company credibility as a builder of serious power plants, not just ordinary industrial engines. In a period when aircraft engines were still temperamental and unpredictable, Hall Scott earned respect by building engines that pilots and trainers could trust to keep running when the margin for error was almost zero. And it did leave aviation behind. After World War I, the aircraft business began consolidating around bigger companies with deeper pockets, and Hall Scott faced a choice. It could stay in a market where scale was starting to matter more, or it could move into a world where its strength still gave it an edge. Hall Scott chose survival. Around 1921, it pivoted into industrial power, trucks, tractors, boats, and stationary engines. Anywhere customers needed engines that could take punishment and keep working. That transition gave Hall Scott a future. In marine work, reliability could mean getting home alive. In trucking, it meant keeping freight moving when a breakdown could wipe out a day's profit. In industrial applications, it meant surviving heat, dust, vibration, and long hours under load. Hall Scott had found the world it belonged in, one where brute force still mattered, and where a company with a reputation for building serious engines could turn that reputation into real business. What Hall Scott did not know yet was that the same world making room for engines like theirs would eventually turn against them. And in 1926, that world got much bigger. The contract that changed everything came in 1926, and it arrived with the weight of American industry behind it. International Harvester, the company that built the tractors feeding America and the trucks moving its freight, approached Hall Scott with a challenge that would either make or break the Berkeley company. The specifications were brutal. International Harvester wanted a heavy-duty four-cylinder engine that could handle sustained loads in agricultural and construction work while maintaining the kind of reliability their customers demanded. The engine had to survive dust, heat, vibration, and the kind of abuse that came with real-world commercial use in environments where the nearest mechanic might be hundreds of miles away. Hall Scott's response was the Model 152, featuring unit construction with a separate cylinder block and overhead cam cylinder head. This was sophisticated engineering for the 1920s, demonstrating that Hall Scott could compete with anyone in advanced engine design. The engine-powered International Harvester's HS-54 and HS-104C models, trucks that would become workhorses across America. The HS-54 found its calling in wheat country, hauling grain from remote farms to railroad terminals over roads that were little more than dirt tracks. These trucks had to survive the punishment of harvest season, when they'd run 18 hours a day through clouds of dust and chaff that would choke lesser engines. The HS-104C became the backbone of construction fleets, moving materials to job sites where reliability mattered more than comfort or fuel economy. The success of the International Harvester partnership proved that Hall Scott could build engines for the emerging heavy-duty truck industry, not just the specialized marine and aircraft markets where they'd made their name. Other truck manufacturers took notice, and soon Hall Scott engines were powering premium models across the industry. What set Hall Scott apart was their philosophy. They built engines for applications where raw power trumped everything else. While other manufacturers chased fuel economy or smooth operation, Hall Scott focused on customers who needed maximum output from every cubic inch of displacement. Their engines were mechanical sledgehammers designed to work when everything else failed. That philosophy worked because the market still rewarded exactly that kind of engine. In the 1920s and 30s, a lot of heavy-duty operators were not asking for elegance. They were asking for something that could survive abuse. A truck hauling grain out of wheat country did not care about refinement. A workboat heading into rough water did not care about efficiency charts. A construction crew on a remote site did not care whether an engine sounded modern or smooth. They cared whether it would start, pull, and keep working when the job turned ugly. That was the world Hall Scott understood. Its engines were not built to win beauty contests. They were built for operators who expected heat, dust, vibration, mud, bad roads, and long hours under load. That gave the company a real place in the American engine market. It was not trying to be everything to everyone. It was becoming known for a specific kind of power, heavy-duty gasoline engines for people who needed brute force first and worried about fuel later. For a while, that was enough. In fact, it was more than enough. The same qualities that made Hall Scott valuable in trucks also made the company attractive in buses, marine work, and eventually military service. The market had room for exactly the kind of engine builder Hall Scott had become. That was why the company could keep growing even as the industry around it got bigger and more competitive. August 29, 1925, marked Hall Scott's transformation from regional success story to national player. American Car and Foundry and J.G. Brill Company paid approximately $3 million for controlling interest in the Berkeley company, serious money that reflected ACF's vision of Hall Scott as a strategic asset in the growing transportation industry. Their plan was ambitious: create a vertically integrated transportation empire that could build railroad cars, buses, and the engines that powered them. Hall Scott's reputation for reliability made them the perfect partner for ACF's bus manufacturing operations, where engine failure could strand passengers hundreds of miles from help. Under ACF ownership, Hall Scott engines moved into markets that had been out of reach before. ACF Brill buses powered by Hall Scott engines became fixtures on Greyhound and Trailways routes, carrying passengers across a nation that was falling in love with long-distance travel. The engines also found new applications in marine vessels, where ACF's connections in the shipping industry opened doors that had been locked to the smaller Hall Scott company. Then came World War II and Hall Scott's moment of ultimate validation. The U.S. military needed engines that could handle extreme conditions, and they turned to Berkeley, California for power they could trust in the field. The Hall Scott 440 Inline 6 became the exclusive power plant for the M26 and M26A one-tank retrievers, massive vehicles that would earn the nickname Dragon Wagon for their ability to drag disabled armor off European battlefields. This wasn't ordinary truck duty. The M26 weighed 40 tons and had to be capable of pulling a disabled 30-ton Sherman tank through Italian mud, over German obstacles, and under enemy fire. The Hall Scott 440 was a monster of an engine, displacing 1,090 cubic inches and producing 240 horsepower at around 2,100 RPM with over 900 pound-feet of torque at 1,200 RPM. The engine was adapted from the Marine Invader design with critical modifications: larger crankshaft journals, new connecting rods, smaller valves, a shaft-driven power steering pump, a PCV system, and a beefier water pump drive system. When a Sherman tank took a hit from German artillery or got bogged down in the mud of the Italian campaign, the Dragon Wagon was built to pull it to safety. The Hall Scott engine had to provide the brute strength needed for that role, but the story also highlighted a crucial contrast. The same gasoline power that was heroic in wartime was becoming increasingly inefficient in peacetime fleets. In the Pacific Theater, Hall Scott Invader engines also powered some Higgins LCVP landing craft, serving as a gasoline alternative to the more common gray marine diesel as American troops went ashore from Guadalcanal to Iwo Jima. These 998 cubic inch engines produced 250 horsepower at 2,100 RPM with a 5.5-inch bore and 7-inch stroke, weighing 2,480 pounds dry. The Invader engines featured overhead valves and dual spark plugs with dual carburetors for redundancy. When Marines were hitting the beach under enemy fire, engine failure wasn't an option. The broader landing craft story was important because it showed how wartime demand kept gasoline engines relevant even as diesel technology was advancing. Hall-Scott played a crucial role in the ecosystem of amphibious warfare, though different landing craft used different engines as the war progressed, and diesel became increasingly common in marine applications. These engines were known for their reliability and power, though they consumed fuel at rates that seemed acceptable in an era of cheap gasoline. A typical Hall-Scott-powered bus achieved only 2 to 3 miles per gallon compared to emerging diesel alternatives. But in the early 50s, fuel costs were a minor consideration compared to the importance of maintaining schedules and avoiding breakdowns on remote highways. While Hall-Scott was enjoying its post-war success, the ground underneath the company was already starting to shift. A new kind of engine was getting better, cheaper to run, and harder to ignore. By the 1950s, the problem was no longer theoretical. Independent testing showed that diesel engines were burning 50 to 60% less fuel than gasoline engines under identical loads. A diesel generator consuming 0.15 gallons per hour could do the same work as a gasoline engine burning 0.36 gallons. In heavy-duty trucking, where fuel costs were becoming a larger part of operating expenses, that difference was starting to change the entire business. The physics were undeniable. Diesel fuel contained about 15% more energy per gallon than gasoline. But that wasn't the real advantage. The diesel engine's higher compression ratio, typically 16:1 compared to gasoline's 8:1, extracted far more energy from each drop of fuel. While gasoline engines wasted energy through their throttle plates and lower compression ratios, diesels converted fuel to motion with ruthless efficiency. At this point, the consequences were becoming impossible to ignore. A diesel truck could travel the same distance as a gasoline truck while burning half the fuel. As trucking evolved from local delivery to long-haul transportation, this advantage was becoming the difference between profit and bankruptcy. The interstate highway system was taking shape, and trucking was becoming a national business where fuel economy could make or break a company. Hall-Scott faced fundamental problems that would prove insurmountable. The company was too small and poorly capitalized to make the massive investment required for diesel development. While companies like Cummins were spending millions on diesel research and building modern manufacturing facilities, Hall-Scott was operating with the limited resources of a specialty manufacturer. The numbers were stark and getting worse. Hall-Scott's annual engine sales remained below 1,000 units throughout the 1950s, while Cummins was building tens of thousands of diesel engines per year. In an industry where economies of scale determined survival, Hall-Scott was becoming a boutique manufacturer in a mass production world. The pressure on Hall-Scott built gradually, like water slowly rising behind a dam. The Depression had hit the company hard, forcing them to cut costs and reduce their engineering staff just when they needed to be investing in new technology. The company survived, but survival wasn't the same as thriving. Peak production of 749 engines in 1947 represented both the high watermark of Hall-Scott's success and the beginning of their decline. After that, annual sales consistently fell below 1,000 engines. The fuel economy gap was becoming a chasm that no amount of engineering excellence could bridge. And in an industry where margins were tightening and competition was intensifying, that difference was becoming a death sentence for any company that couldn't adapt. In 1954, Hall-Scott made their final desperate attempt to stay relevant in a world that was moving beyond them. The Model 590 represented everything the company had learned about gasoline engine technology over 5 decades of development. This would be Hall-Scott's last all-new engine in a game where the rules were changing faster than they could adapt. The 590 was an inline-six gasoline engine with 590 cubic inches of displacement, using a square design with bore and stroke dimensions of approximately 5 inches each. This configuration allowed higher RPM operation and better breathing than the long-stroke designs that had characterized earlier Hall-Scott engines. With the ability to rev to 2,800 RPM, the 590 could produce 245 to 250 horsepower, along with 500 to 530 pound-feet of torque. These were impressive numbers for a gasoline engine in the mid-50s, demonstrating that Hall-Scott's engineering team still knew how to extract maximum performance from internal combustion. Hall-Scott offered the 590 in both vertical and horizontal configurations, recognizing that different applications had different space constraints. The horizontal version became particularly popular in fire trucks, where the low profile allowed for better weight distribution and easier maintenance access in cramped engine compartments. For a brief moment, the fire truck market seemed like Hall-Scott's salvation. Fire departments across America valued engines that could deliver immediate power without the cold weather starting problems that plagued early diesels. Fire departments needed throttle response and readiness for sudden demand, making Hall-Scott's gasoline engines a natural fit for emergency service, where response time could mean the difference between saving lives and watching buildings burn. But even this refuge was temporary and limited. As diesel technology improved through the 1950s, the cold starting problems were solved with better glow plug systems and improved fuel injection. Fire departments began to realize that diesel engines offered not just better fuel economy, but also longer service life and reduced fire risk, ironic advantages for fire trucks. The 590's sales disappointed against Big 3 V8 competition, and even the fire truck market couldn't support a company that had once supplied engines for major military contracts and commercial fleets. Hall-Scott was discovering that being excellent at gasoline technology wasn't enough when the world wanted diesel efficiency. The beginning of the end came in 1954 when American Car and Foundry made the cold calculation that Hall-Scott was no longer worth keeping. They were facing their own financial pressures as the railroad car business declined and competition intensified in their core markets. Hall-Scott, which had once been seen as a strategic asset, was now viewed as a distraction that consumed resources without generating adequate returns. The company lost access to ACF's financial resources, manufacturing infrastructure, and dealer network. They were now a small, undercapitalized company trying to compete against industrial giants like Cummins and Detroit Diesel, who were investing heavily in diesel technology and building modern manufacturing facilities. Despite their independence, Hall-Scott remained undercapitalized and unable to make the massive investments required to develop competitive diesel engines. The final blow came in 1958, delivered not with drama, but with the quiet efficiency of a business transaction. Hall-Scott sold its engine division to Hercules Motors Corporation of Canton, Ohio. The Berkeley plant that had hummed with activity for over 50 years fell silent as production moved east. By 1966, Hercules had effectively ceased almost all Hall-Scott-related production. Only very limited parts support continued thereafter, and even that was sporadic. The company disappeared as a distinct business by 1960, and the final Hall-Scott engines were produced by Hercules in Canton before even that limited production ended.